so again, linear regression is modeling data that follows a generally linear pattern. Okay? And we're going to do this by using a linear equation. Now, there's a story here about why it's called a regression. You can read this for sake of time today. We won't do that.
I like talking.
Great.
I don't know if they do.
I hope they do. All right, so what we're doing here basically is, while our data is not exactly linear, we're going to try to fit it to a line. Okay? One of the ways we can do this kind of in a approximate way is by using a mean point and then drawing a line through the mean point. I'll show you what I mean here in just a second. Okay? The mean point has these coordinates, x bar, y bar. Okay? You don't necessarily need to write anything down right now other than just what a mean point is. Okay? So we're going to do other examples where we're actually finding the regression line, and that's what we're going to focus our time on. All right? But let's just take a look at this data. Here we have mass hanging on a spring, okay? And if we have 0 grams on the spring, it's 17.7 centimeters long. And then all the way up, we measure how long the spring is being stretched, all the way up to when we have 250 grams, and it's stretched out to 27.8 centimeters long. Okay? And you can see we have a scatter plot of our data. And also I found the mean point. Okay? The mean of 0, 50, 100, 150, 200, and 250 is 125. Okay? And the mean of these lengths is 23.15 centimeters. Yes?
Is this the same thing as linearization?
Basically, yeah.
So is there a button on your calculator that does the graph for you, linearizes it?
We're gonna look at using your calculator to do this, yeah.
But you can do it.
Yes, you can.
So for the exam, we don't have to memorize the other formula. Do we have to know how to do this and calculate it?
No. So here's the basic idea of what we could do. If we just wanted an approximate idea of how this could be modeled, what we would do is, first of all, plot this point, 125, 23.15. Okay, so let's see, 125 would be about right there, so we're going to go straight up. And 23.15 is going to be, about right there. Okay? So our point that we have, our mean point would be right here. Okay? And what we could do to model this, again, this is an approximation, is we would draw a line going through the mean point, and we would draw it in such a way that we had about the same number of points above it as we had below it. Okay? So you can see here, these 2 points up here are a little bit below it, these 2 are a little bit above it, these 2 are kind of right on it. All right, so that would be an approximation of a line of best fit. And it's called you might see it referred to as a line of best fit by eye. Okay? We're just eyeballing it. So how can we find a line of best fit, more accurately? There are formulas that you can use to do this, but we're going to focus on how to do this with our calculator. Finding the least squares regression line, okay? Now, notice the definition here. It says that what line we're finding here is the line passing through the data such that the sum of the squares of the distances from each point to the line is at a minimum. In other words, notice over here we have these 4 points, and we have this least squares regression line going through the middle. And these distances, if it's the least squares regression line, then when you find these distances and square them and add them all up, it's the smallest it can possibly be. Okay? Does that make sense? We want to minimize how far away all these points are from the line that we get. Okay? Now, how many of you have the 84, 83 or 84? Okay, most of you. And let's see, a couple of you had the Nspire. All right. On the Nspire, what you want to do is go to your spreadsheets. You'll type the data into 2 columns. Okay? No, if you have an Nspire.
Can you move that a little bit to the left?
Okay.
So I can finish the...
And then what you want to find is your linear regression. Okay, so you're going to get that data, and then you can go into your menu. Once you type in that data, you'll go into your menu and just for a second. I think it's under stat calculations. We can find it once you guys get the data in. Those of you with the 84 or the 83, I can show you this here because I actually have it up. I can put on the screen. Okay, let's put in. We're gonna put some data in here where a city was considering the effect, or numerous cities were considering the effect of having speed cameras in operation on the number of car accidents. Okay? Now, they're ignoring a lot of other variables. They're ignoring, how good are the drivers, period, in that area, that sort of thing. But they're just focusing on, is there a relationship between the number of speed cameras and the number of car accidents? And if so, what would be our overall model that we could use? Okay? So, we're going to input this data for both of you. You're going to want to put it in. If you have the 83 or 84, go to Stat Edit. Okay? And you can just type in the number of speed cameras as your list 1 and the number of car accidents as your list 2. Okay, so I'll give you a moment to do that.
I have a question on the list. Yesterday, when I was doing problems with lists on my calculator, I accidentally deleted list 1 through 5, and I don't know how to get them back. It just started with 6 and
Okay, so do you see empty spots up on the...
It doesn't even show empty spots. It just starts at list 6 and goes to list 10.
Okay, I think if you go up to list 6, hit delete, it'll give you the opportunity to type in something else.
No, we just deleted list 6.
Hang on. Let me try this. Just. Okay. Just try doing this. Go up to whatever list 7 you're up to now, and try just hitting second list 1 and enter.
Is that error?
Okay. Then I think what I would do, let's see, let's go to, try going to memory,
Where is that?
and hit 4, clear all lists.
Wait, where's that?
Second plus sign, and hit clear all lists, number 4.
Okay.
And then go back to stat edit. Is it showing up now? No? You know what? Do this. Go home or hit quit and just do like you can store things in a list using the curly brackets. Okay? And then if you just put like a couple things in and then hit stow L1, that ought to give you, it ought to put it back then. If it doesn't then
Hey, let's see. It says it's stored, but when I go to list, it doesn't.
Why don't you just see if there's a reset button on the top of the
Oh, you do?
Yeah, when you're in this thing, press the insert button, and then second list, and then put in this one.
Ah, thank you.
I didn't
Okay,
see
here,
it.
let me show you. What he just said, once you're here at the edit, okay, let's say that I delete list 2. So now I have list 1 and list 3. What he's saying is if you hit second insert, and then see the blue list, so hit second list, and just, I need to put L2 back in, so hit enter, and it actually gives you, notice how it's blank up here, but it says L2, just hit enter, and now it has a spot for it. Thank you, Tony. All right, meanwhile, the rest of you should have your data inputted by now. Okay. Uh-oh. I don't have the same number. Did I?
Then the same thing happened to me. I can't do it.
7? Oh, wait, because I missed 7.
I told you to 7 and you looked me away.
I didn't hear you say anything.
I'm such a gay mood. Thank you so much. Like, I really have. It worked for me. I'm serious.
5, 16, 25, 15, and 19. Okay, so now we have it. Is anyone else still working on getting their data put in? Okay, so at this point, what we need to do is quit out of this. And notice it says construct a scatter diagram, okay? I showed you how to do that with stat plot earlier. If we do stat plot, number 1, we're going to turn it on. And notice here's just a scatter plot. X list is L1, Y list is L2. And now if we go to graph that, I need to make sure my window is set so they'll all show up. So you can see here we're going to go X from 0 to 30.
Wait, where do you find the graph card?
What?
I selected graph. Second.
Okay. We'll get to that. I'll show you in a sec. All right, so here's our scatter plot. And by the way, here's one. I might have put in a, wait, no, a wrong value. Oh yeah, right here. That should be a 48. Okay, let's look at that graph again. There we go, that looks a little better. All right, so there's our scatter plot. Okay. And then what we want to do is we want to calculate R. And also we want to get a line of best fit. Okay, we're not just going to eyeball it. All right. But we're going to find a line of best fit. And the way we're going to do that, if you look at this, we're going to hit stat and calculate. Okay? So stat, calculate, and then notice right here is a linear regression, AX plus B, number 4. Okay? We're going to hit that and hit enter. Okay? You'll notice, however, while I did get enough to get my regression line, I didn't get R. Okay? And here's the thing. The R value that we were calculating by hand, your calculator will actually do as it finds the least squares regression line. You just have to make sure that it's telling you to. Now, did any of yours show up with an R and an R squared?
How did you mark it wrong? You just didn't click the right function?
No, I clicked the right function, but we need to make sure our settings are right. Did you get an R and R squared?
I wasn't able to.
Okay. Is anyone getting an R or an R squared?
I'm trying to.
Okay. Okay. Did you get an R and an R squared?
No, Timmy.
Hit stat. And hit the right arrow to calculate. And then number 4 is linear regression. Yes.
It just gives A and B.
You probably your lists. Stuck in its memory that something's wrong when it's not. Okay, so here's the deal. If yours is not showing, if yours does not show R and R squared, here's what you need to do. See memory above the plus sign. MEM. Or I'm sorry, not memory, catalog above 0. You're going to hit second catalog, okay, and this lists every function your calculator is capable of doing. All right, so we're going to scroll down to the D's, and there's diagnostic off and diagnostic on, okay? We want to make sure the diagnostics are turned on, so we hit enter. And then hit enter again. And if we re-enter the linear regression, please listen. If we re-enter the linear regression, notice now we get an R squared and an R. Okay, so notice here we have R as a negative 0.878. All right, so let's see what that gives us. Okay? All this is so that we will have, okay, R a negative 0.8782, okay? So that's that solution. Point. What does that tell us about the number of speed cameras, the number of accidents? It seems like there's a negative correlation if we went back and looked at our critical value table. Okay. How many cities did we have? 16. Okay, so we'd have 14 degrees of freedom. So we need a 0.497. Our correlation clearly gives us more than 0.497, so it's significant. It looks like it's a pretty strong one as well, and a negative one. Okay. And then also, from this, we have our line of best fit. Our line of best fit, notice it's AX plus B. So A is the slope, a negative 1.06. X plus B is 52.0. Okay? And we can then use that to predict a lot about the situation. We could predict, hey, if we have so many cameras, what is that going to do to our, or how many accidents could we expect? Okay? Also, look at this last question. We'll cut it off at that. Your line, where's the y-intercept? Algebra 1 or pre-algebra question here. What's the y-intercept? 52, okay? 52. What does that mean in light of the situation?
We'll have the lowest with the first values.
What do you mean?
When you start, when it just has the y-axis, so if you start at 52.
What do we mean we start at 52?
Like that's the lowest values.
Not the lowest, it would be the highest. So the highest number of accidents, and that would occur when?
When you're going.
If there's no cameras. If there's no cameras, we would predict that there's going to be about 52 accidents. Okay? As we put cameras in, you can see from the slope here, every one camera is going to eliminate potentially one accident. Okay? Now, extrapolating that out, does that mean if we put 52 cameras, we're never going to have an accident? Obviously not. Okay? But tomorrow we're going to talk about interpolation and extrapolation. Okay? And we'll see kind of the limits of extrapolation. But that's how we can model it. All right? Yes. Yes.